Hey guys, welcome back. So now we are going to discuss about the constructional difference between an ME engine and MC engine. However, the core working principle of both the engines are same. That means both are two-stroke diesel engine, so they'll be working on the same cycle. Construction wise also not much of difference is there. Okay, so first of all, let's try and understand the basic working principle of a two-stroke engine, and then we will go into the details about what exactly is the different in ME engine from a conventional MC engine.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
So here in front of you, we are trying to explain a two-stroke diesel engine cycle. We have a cylinder, a piston, a crosshead, connecting rod, and so on, right? So cylinder, then exhaust valve. This is shown to be a fuel injector through which the fuel will enter, and these are scavenge ports. This is where the air will enter from. So what exactly is happening is piston is moving up and down. So in a two-stroke cycle, let's say the piston is at this position, bottom BDC here, bottom dead center, and by the time scavenge ports are exposed to air chamber, or you can say air receiver, so air will enter and fill up the space. This is the same air that is going to be used for combustion, right? Now when the piston starts to move up, this is the time when scavenge ports closes. SP scavenge ports, they close at this position, but exhaust valve, this is the exhaust valve which is still open and will continue to be open out till some time, and at this very position where I've written exhaust valve, this is where the exhaust valve actually closes, and now the chamber is blocked, means the combustion chamber or the cylinder is now airtight. No air or anything can escape this area. It's a closed chamber now, and beyond this point, if the piston moves up, this is going to compress the content of this chamber. So if presently we have air, so air will start to get compressed. If we try to see the same thing in this P and, well, this is the distance, this is a TDC. So from BDC just wait, let's say this is the BDC point. So from BDC to TDC, this is what is being depicted, pressure and the stroke. So here you can see the pressure is gradually, initially it is stable, but the moment exhaust valve closes, the chamber is closed. The chamber closes, and at this very point, pressurization starts to happen, or you can say this is where the exhaust valve closes and the pressure will start to rise. Now pressure will start to build up, and it goes up, goes up, goes up, goes up, goes up, goes up. At TDC position, this is a TDC, I'm expecting the compression pressure to be maximum because it has compressed to a maximum degree. This is that position, this point. Now, since the pressure is rising, we know that PV by T is constant. So when the pressure is rising, we also expect the temperature to rise. This is happening very fast, right? So there's hardly any time for temperature to escape, or heat to escape actually, or temperature. So of course the temperature is going to rise, and the temperature is so high that it is beyond the auto ignition temperature of fuel. So the fuel does not need any spark plug here for ignition. Temperature itself is so high that the moment you inject the fuel is going to start to burn. So this is a fuel injector, and nearby TDC will start to inject the fuel through some different process, but you just, for the time being, you imagine from somewhere fuel is coming in, and this fuel is getting injected into the combustion chamber. And this fuel, of course, when it starts to burn, it will produce a lot of heat and a lot of gases. So hydrocarbon, which is a liquid, was liquid initially, and then in form of droplets, then this is going to get converted upon combustion, reacting with oxygen from the air. This hydrogen will form H2O, and this carbon in the fuel, this hydrocarbon, this is the fuel now. So this carbon in the fuel will produce CO2. So these are the byproducts plus a lot of heat. So you see, we are getting more number of gaseous matter than initially that were there, and also heat is being produced. So heat plus more gases that are produced will tremendously increase the pressure inside, and that should happen ideally beyond the TDC, because this is when the piston will starts to come down. It should not happen, this high pressure should not come before TDC, otherwise it'll kind of braking, it'll impose a braking effect. So this pressure, tremendous pressure rise should come after TDC. So if you forget about this red line, suppose I do not inject fuel. This blue line, blue is the curve that will be, basically it will be tracing. Piston going up, it is compressing to this value, whatever that may be. We call this as a PCOM value. PCOM means peak compression. The pressure at TDC is peak compression pressure. But since there is a fuel injection, I get additional pressure. So this is an additional pressure I'm getting, and this is the effective work done. So this is what I'm doing. I'm putting some energy in form of fuel, and I'm getting some pressure, which again will help me drive the crankshaft, which eventually drive the propeller at the after the ship. So this engine, basically it's a propulsion engine. Basically it is propelling the ship. Propeller is connected to this engine, and this two-stroke diesel engine is how it's propelling the ship. So there will be not one, but there are many units starting from number 5. It could be 5 units, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it all depends. Smaller ships or ship type, it also depends on ship type. Like container ship usually have more cylinders and all. Anyway, so this is the two-stroke diesel engine cycle, and after a certain time, what is going to happen? Exhaust valve will open, and when it is coming down, so when exhaust valve open, then suddenly the pressure will drop, and again the cycle, and then the scavenge port will open, and when the scavenge port open, the air will drive out the remaining exhaust gases from the exhaust port. This is exhaust valve, and the path that is given, right, exhaust path, and this is how the cycle will complete when it again comes back to the same position, BDC, where it starts from. So here we have BDC again. So this is the two-stroke diesel engine cycle, and this is still the same in ME engine as well. MC engine, ME engine, no change at all, right? Okay, so that's all for now. See you in the next video.